Okay, I'm going to start off by showing you a data-driven application. This happens to be an ASP.NET application. It has a SQL database, SQL Server database on the back end. It turns out that this particular vulnerability I'm going to show you doesn't really matter if you're using ASP.NET or PHP or SQL Server or MySQL or whatever. Anytime you have SQL on the back end and you're allowing a user to supply input, like we do here, there's the potential for this particular vulnerability. So Fabricam's product database, we provide some input, we hit search, it goes and looks up some entries, some rows in a table that have the criteria we were looking for. So there's also an MP3 player in here, I think I can search for, yeah. Now if you were going to try to attack this application and try to discover if there was a vulnerability, one of the things that you might think about is how the SQL statement's being constructed. So if you look at the table here, you think about what that SQL statement might look like. Select some columns, whatever, from some table where description, let's say, is like %, and then user input goes here, right? Order by, whatever. So if you have a naive developer who's not aware of this sort of problem, they might very well be concatenating your user input, your search string, directly into the SQL statement through string.format or through some other mechanism. So what would happen if we did something like put a single quote in there? If we typed a single quote into that search box, we should get an error because now we've got an unbalanced number of quotes in the SQL statement. If we try that out, we can see whether or not there's a problem here. Now in this particular application, since I'm running it right on the server, I can see the exact error message. I'm not getting custom errors, which is what I'd see if I was remote. But still, if I see an error because of that, then I have a very good clue that this application is vulnerable to a SQL injection attack. So if I go back in here, I might try to see the whole database by doing this. Let's try to play around with this a little bit, because now that I put the quote there, I'm actually outside of the string and I'm into the SQL statement itself. And I can start changing the where clause. I'll add my another clause to the where. Or 1 equals 1, or true, basically. And then comment out the rest because I don't want this extra quotation mark messing me up. So let's go ahead and take that as our input. Paste that in there, or 1 equals 1. And sure enough, there isn't much in that table, but that's all. Those are all the records that are there. You can see them. So at this point, now we can start playing games. We can start poking around and seeing what else is there. I can add other SQL statements on besides just the select statement. All I have to do is just comment out the rest of the, the rest of the programmer's SQL statement here. So I'm going to add a union, select, null, 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 because I believe he's probably selecting 3 columns. And I search for that, and sure enough, I get an empty column at the end of this, and I can play around with this. Is this the description field? Right? Yeah, it is. See, so it's kind of obvious how this select statement works. It's pretty easy to manipulate it. And now we can start looking for stuff in the database. This is one of the more mild attacks that we can perform. I can start poking around and seeing what's there. If it's SQL Server, we'll be able to discover what version of SQL Server is running. So, we can see that we're using SQL Server 2008. The version of the operating system. You can see the service pack that's running. We can also see what level of privilege we're connecting to the database with. Let's see, system_user. Discover what user account's being used. It looks like a custom account is being used to connect here, so I'm not quite sure what level of privilege we have. We'll test that out later on. At this point now, I want to start poking around inside of this database instance and see what else is there. So let's go look for, let's select name from sys.databases. That'll tell me the list of databases on this instance. This is probably the database that I'm looking in here, right? So let's drill into that now and see what tables are there. So let's go look for table name from We want to go to the Fabricam database, .information schema, .tables, do a search for that. Oh, there's a products table. Okay, that's the table we're looking at here. But then there's also a users table, which is intriguing. Let's take a look at that. We're going to look for column names from columns where table name equals users. Okay, search for that. All right, so now we've got all the columns for the user tables. We've got email, we've got credit card information, we've got passwords. We can start dumping that stuff out if we want to now. And this is where things start getting a little more interesting. So I'm going to dump out the user's email address, put a comma, put the password, put a comma, put the credit card number. You know, you get the idea. I don't have to dump the whole thing. And I'm going to dump that out from the users table. It's a really good thing that this search box allows me to type so much in it, doesn't it? Would it make any difference at all if that search box had a limit on the length? Or if there was JavaScript that was validating this stuff in the browser? You know, if you think about that a little bit, you'll realize the answer is no, it doesn't matter, because I don't have to use this form to submit HTTP requests to the server. I could use, you know, a Perl script or a tool. There are actually tools that will automatically exploit these sorts of bugs. But anyways, if I search for that, you'll see that I can basically get a dump of the user database. Now, there's other more malicious things that I can do besides that. For example, drop table users. Right, what's to stop me from doing that? Well, the only thing that'll stop me is if the web application doesn't have permission to do that. In this particular case, apparently whoever designed this web application was smart enough not to make themselves the database owner. They obviously don't have permission to drop tables. That's a good thing. So sometimes that's the only thing that'll save you is the level of permission, you know, connect to the database with least privilege. We'll talk about least privilege later on in this lecture. What else could I do? Oh, I know something that I could do that would be a little more, well, a little less invasive than dropping a table. How about if I just change the price of that MP3 player? So how about update products set price equals 0.01. That's a little cheaper. Where SKU equals V2K 1009. I guess I don't need the where clause. I could just do it for all of them, but comment out the rest, hit search, and doesn't look like anything changed, but if I refresh this page now and I look for that MP3 player, we should see that it's a little cheaper now than it was before. So apparently the developer, you know, didn't let the web application drop tables, but it did allow it to do updates, which is probably more than this application really needed as far as privilege goes. Now let's go off and take a look at the code behind this that's allowing this vulnerability to happen. If we go up, you can just see this is the code for the search page. We've got the button handler for when you click search. And essentially the really bad code's right here, where we're taking our SQL command and we're setting up the SQL including inside of it unfiltered user input. That's the danger. We're using string.format here to do this. And that allows the attacker to, you know, basically control the SQL statement. So let's fix this. There's a number of ways of fixing this. Certainly one of the ways you could do is you could replace all single quote characters in the untrusted input with double quote characters. You could, or with two single quotes. You could basically escape the input. And that is certainly one way to approach this, but I like the approach of using parameterized queries because that ensures that as long as I'm always using a parameterized query, it ensures that the data will be properly escaped for me. So command.commandText equals, instead of saying string.format, I'm just going to go ahead and use the direct SQL without injecting any user input into it at all. And I'm going to replace this with a parameter. So let's say input. Okay. So now that I've got that, now I can set data. I can supply data for that input. Command.parameters.add with value. That's the one that I like to use. let's see, input is what I called my parameter. I want to set that to be search string that I got out of the text box up there. Now, because I want to allow wildcards around this, I'm going to add in the percent wildcards around this so that it can be box and it will find anything with box in it, so on and so forth. And with that change, let me go ahead and save that and switch back over to my application now. If I refresh that app so it recompiles it, there it goes, it's recompiling. Hit box. Box should still work, but none of the other attacks that I used, let me just put a single quote here, like or 1 equals 1, that's an example. Right? Your search returned no results. So what this is saying is that it's treating that entire string as data, and it couldn't find any description that looked like that in the table. And that's what you want. That's the sort of behavior that you want. So the basic pattern here is you accept user input into your application, and you pass that user input to a system that basically chokes on it or does something that you don't want to do with it. So we need to just control where user input goes, and really, how it gets there. We need to filter it. We need to properly escape it. We just need to treat it with respect. And one of the first things that you need to think about is, where does user input come from? User input could be as simple as the URL that's being passed into you. It could be form variables. It could be the cookie that's being passed to you. It could be, any myriad of things. Just think about, where did that input come from? Could it have been manipulated by the user? And if it was, I better be very, very careful with it.